Resume. So today, like I said, we're taking a little detour and talking about radicals. Now, radical and square root, they're the same thing. A lot of times, kind of like middle school, starting into high school, everybody kind of says square root, square root, square root. Then at some point, they start transitioning to the word radical, but it's the exact same thing. I usually just kind of interchange them a lot, just so you're used to both vocab, but it's the exact same thing. Now, before I kind of really start into this, I want to ask you a question. If I asked you, what is the square root of 25? What is the square root of 25?
5.
5. And it comes out even, because 5 times 5 is 25. So if you have something underneath a radical, if you were to break apart 25, and like I said, you don't have to write this down yet, you get 5 times 5. So if underneath the radical you have 2 of the same number, you can take 1 out. You can take 1 out. So that's basically what we're going to be looking at when we're multiplying radicals, is we're going to see what can I simplify by taking it out. So, kind of in through here, I'm going to put some steps because I've got room to write. So step number 1, factor the numbers under the radical. And when I say factor the numbers, that means I want to know what numbers multiplied to give me that number. That's what I mean by factor. So looking at the first problem, 2. Can I break apart 2 any more than it already is? No, it's already a prime number. I can't do anything else with that. So square root of 2 is just going to say square root of 2. Square root of 10, now this one can break apart, because 10 is what times what? 5 times 2. So instead of writing 10, I'm going to write square root 5 times 2. So that was step 1. Step 2. Any number that is duplicated right in front of the radical. So kind of at the beginning, we said the square root of 25 was 5, because 25 is 5 times 5. So a 5 can come out. So on this first problem, I've got a 2, a 5, and a 2. So I'm looking at all of the numbers underneath the radical, no matter which radical it is. Do I have any numbers that have a duplicate number? 2. So therefore the 2, I'm going to write in front of the radical. And then anything left over just stays under. So what's left over? So 5 is going to stay under. So usually when I talk about this is these 2, because they have the same thing, they're going to go out on a date. So they're going to go out on a date. This 5 doesn't have anybody to go on a date with, so therefore they have to stay home. So the 2s went out, the 5 stayed home. So I get 2 radical 5. You okay there?
Yeah.
So number 2. Well, first, I'm going to put one more step here, even though we're not going to need it for a little bit. So step 3 is to multiply any numbers in front of the radical and to multiply any numbers under the radical. And we actually won't need that step for a little while. But if after I pull things out or if after things are left under, I basically have to do a little bit of cleanup. So anything out front gets multiplied together. Anything underneath gets multiplied together. So number 2. Can I factor a 2 or a 3?
No.
I mean, I'm pretty well stuck with them. So therefore, since I'm stuck with them, is there any number that has a duplicate? No. So therefore, number 3 is to multiply anything in front, multiply anything underneath. So I'm just going to multiply these guys together, and I get radical 6. So that one I really can't do much of anything with. I'm just sticking them together. Okay with this, Richard? So that was number 2. Any questions so far? Before I slide on. We good? Any more time to write? Moving on. Number 3. So step 1 was to factor the numbers. Can I factor a 2? Nope, it's already prime. Can I factor a 4? Yes. 4 is 2 times 2. So that's step 1. Step 2, if there's any number that has a duplicate, pull it out front. Is there any number that has a duplicate? The 2. So therefore, the duplicate gets pulled out front. Did I have anything left over? I mean, did I take all the 2's out? No, I still have 1 2 left over, wasn't it? So this 1 2 that was left over, it's kind of like the third wheel. Nobody wants to be the third wheel on the date. So these 2 went out on the date. This one had to stay home. So 2 square roots of 2. Number 4. Can I factor the 3?
No.
Nope. Can I factor the 6?
Yeah.
And 6 is
2 times 3.
2 times 3. Is there anything I have a duplicate of?
3.
I have a duplicate 3, so the 3 comes out. Is there anything that had to be stuck back under?
2.
2. So 3 radical 2. 3 radical 2. Now the next one's slightly bigger numbers. So let's look at the next guy. 20. Can we factor 20?
Yeah.
What does 20 factor as?
2 and 10.
2 and 10. So I have a 2 times a 10. And then this 10, I'm going to actually just leave a 10 because I already have a partner. And I'm going to leave that a 10. So because this broke down as 2 and 10, I already had a 10, I can just leave it there. Now, if that wasn't the case, this 10 I would have broken down again into 2 and 5. This one could have broken down as 2 and 5. But I already had a pair. So therefore, 10 had a partner. 2 didn't, so it stayed in. So 2 or 10 radical 2. 10 radical 2. So the first 5 didn't have any numbers in front. The last 5 have some numbers in front. Now we're not going to do anything with the number in front to begin with. It's just going to hang out for a while. So the 4 I'm not going to do anything with. 15 I'm going to factor, same as I did before. So what does 15 factor as? 3 and 5. Times, oops, that looks like a 6. This negative out front, I'm just going to change to -1. 8. How can 8 factor? 4 and 2. And because 4 is actually 2 and 2, 8's actually 2 times 2 times 2. Because I get 4 and 2, but then the 4 can break down again. So it's actually 2 times 2 times 2. Now, if it's already out front, it's just going to stay out front. So the 4 is already out front. So I'm just going to pull it out front. The -1 is already out front. So I'm going to pull it out front. So the 2 numbers that were in front of the radical, I'm just pulling to the front. Now, is there anything I have a pair of? I have a pair of 2's. So the 2's also going to come out front. Why does it keep changing math? Underneath the radical is everything left over. So what's going to go back under?
3, 5, and 2.
3, 5, and 2. 3, 5, 2. So all of those went back under. So this is kind of where that third step comes in, is I need to do a little bit of cleanup. So anything out front, I need to just multiply together. So 4 times negative 1 times 2 is going to give me what? So negative 8 out front. Radical, 3 times 5 times 2, 30. So negative 8, radical 30. So that's where the third step comes in. So far, so good? Before we move to the last 4. Last 4. Then we'll get to division. Number 7. So like I said, the numbers out front are just going to hang out for a little bit. 15 is what times what? 5 times 3. Times, the negative I'm going to change to negative 1 again. Now 12, 6 and 2, but 6 isn't all the way down yet. So 6 I can actually break into 2 and
4. Wait, 2 and 3.
2 and 3. Because this 12 started out as 2 and 6. 2 I'm okay with, but 6 is actually 2 and 3. So when I'm breaking the numbers down, unless I can already see a partner, I want to break it down into prime factorization. So prime means it's the numbers that won't break down anymore. I'm sure you've done prime factorization in the past, but it's been a while. So that's where we are right now. So everything out front is just going to stay out front. So 3 is already out here. Negative 1's already out here. Now I got to start pulling anything else that can come out. So what can come out?
2, 3, and 5.
The 2's and the 3's, but does the 5 have a partner? No. So the 3 can come out because the 3 had a partner. The 2 come out because the 2 had a partner. The 5, it's lonely. It stayed home. So the 5 stayed up. Now I just got a little bit of cleanup. 3 times negative 1 times 3 times 2. Negative 12. And then, wait a minute. 3 times 3 is?
Oh, no, it's 18.
It is 18. I'm going to say negative 12 doesn't sound right. 3 times 3 is 9. 9 times 2 is 18. And then this will change it to negative 18. Radical 5. So negative 18, radical 5. Number 8. I can't do anything with that guy. So it's just going to stay 5. Times negative 4. 15, we've got a lot of 15s. What did it break into again? 3 and 5. So negative 2, negative 4. What else can come out front? What has a partner? So the 5 can come out front. And what's going to go back under? 3. So negative 2 times negative 4 times 5. What's negative 2 times negative 4 times 5?
Is that 40?
It would be 40. 2 times 4 is 8. 8 times 5 is 40. Negative times a negative is a positive. Positive times positive, I get a 40. So 40 radical 3. Number 9. I mean, right away, I actually see that both of them have a 10. I mean, I could break it into 2 and 5, but why bother? Because they're already partners. So So I'm not even going to bother breaking these guys down. I'm just going to pull them out front. So negative 2 is already out. 4 is already out. 10 I'm going to bring out because it's already partnered. If you would have broken it down, not a big deal. It would have been 2 and 5, 2 and 5. So 2 would have came out, 5 would have came out. Nothing was left underneath. So negative 2 times 4 times 10 gives me negative 8. And the last one on this side. Negative 4. We've had lots of 15s, 5 and 3. I tried to keep everything relatively small so we end up with a lot of numbers that were duplicated, but that's not a big deal. Times negative 2 is going to hang out. The 10 is going to break into 5 and 2. So negative 4, bring it on out. Negative 2 is already out. What can come out? 5. And what has to stay under? 3 and 2, or 2 and 3. So again, this last one I got a little bit of cleanup at the end. So everything outside multiplies together, everything inside multiplies together. So negative 4 times negative 2 times 5, 40. 4 times 2 is 8, 8 times 5 is 40. Negative times a negative is a positive, I keep the positive. Radical, 3 times 2, 6. So that's kind of the key idea when you're multiplying radicals. Multiplying is basically the same thing as simplifying a radical. I just want to pull out everything that I can possibly pull out. Are we okay on the front?
Yeah.
Moving to the back. Now, the back, we have fractions. Fractions are just division. So the back is all division. And generally we show division by using a fraction. So, step 1. Reduce the numbers under the radicals. So same as any fraction, if you can divide both numbers by something, I'm going to do that. And radicals can reduce with radicals. And it makes smaller numbers so they're easier to work with. So number 11 here, I've got a 15 and a 20. Is there any number I can divide both of those by to make this a smaller problem? 5. So I'm going to divide both of these by 5. So I'm reducing it. So the radical is still there. I didn't do anything with it. 15 divided by 5 is 3. Over 20 divided by 5 is 4. So that's step 1. Step 2, simplify the radical. Now, reducing the radicals isn't the same thing as simplifying radicals. Simplifying is if I can take something out. Well, the 3 I'm pretty well stuck with. But what's the square root of 4? 2. So therefore, radical 3 is just going to stay radical 3. Radical 4 is going to change to 2. So that is my answer. Now there is one more step that we're not going to see for a little while. But the third step, which will show up here at some point, is to reduce the whole numbers. And that's the big thing is when you're reducing, radicals can only reduce radicals. Whole numbers can only reduce whole numbers. You can't reduce a radical and a whole number at the same time. So number 12. I have a 5, I have an 80. What can go into 5 and 80? 5. So reduce what's underneath the radical. So both can divide by 5. Radical's still there. 5 divided by 5 is 1. Radical's still there. 80 divided by 5, 16. And most of the time, you're probably not going to need a calculator for this stuff. But occasionally you might. Like if you can't get 80 divided by 5 pretty quickly, you might have to grab a calculator. But most of the time, you're not going to use calculators on these things. Step 2 was to if I can spell simplify. I'm going to simplify. I lost a whole syllable. Simplify the radical. What's the square root of 1? Square root of 1. Can I simplify square root of 1?
No.
What's 1 times 1? 1. So the square root of 1 is actually just 1. So I don't even need the radical. We're just going to change it to 1. So if you have a 1 under the radical, just change it to 1. Square root of 16. Careful. What times itself is 16?
4.
4. See why it's 4?
Yeah.
Okay. So I get a 4. 1/4. It says to reduce the whole numbers, but there's nothing to reduce. So we're done. 13. Can the same number go into 5 and 16? Nope. So I can't do number 1. I can't reduce the numbers underneath the radical. 2 is to simplify the radicals. Can I simplify radical 5?
Yeah.
I mean, 5 is just 5. I can't really do anything with a 5. So the 5 is just going to stay 5. Can I simplify radical 16? Yes. Because the square root of 16 is 4. I can't do anything more with that. I can't reduce whole numbers. So that's my answer on that guy. I have a 6 and I have a 32. What can go into both of those?
2.
2. So we're going to divide both by 2. So reduce the radical. I get 3 and I get 16. Step 2 is to simplify the radical. So can I simplify radical 3? Can I simplify radical 16? No. It changes it into 4. And that's my answer. We good? Any questions? Slide on. Can I reduce 25 over 16? I mean, nothing goes into both. Can I simplify square root of 25? Yeah, square root of 25 is 5. Square root of 16 is 4. I can't reduce that again. I can't simplify again. So we're done. It's just 5/4. Do not change these to mixed numbers. Don't try to change that to a 1 and 1/4. Don't do that. It just makes things more complicated. So just leave it 5/4. 16. I've got a 15 and a 4 under the radical. Can I reduce a 15 and a 4? Nope. So next is to simplify. Now 15, yes, it breaks apart as 3 and 5, but that still doesn't help me. So I'm just going to leave it 4 radical 15. I've got a 3 here with a radical 2. Can radical 2 simplify? What's the square root of 4? 2. So this is actually 3 times 2, which changes this to 6. Now this is where that third step comes in, because the third step is to reduce the whole numbers. So radicals reduce radicals. Whole numbers reduce whole numbers. So I'm only looking at the 4 and 6. The 15 I can't do anything with at this point. I'm stuck with it. But the 4 and the 6 both divide by what? 2. So my final answer, 2 radical 15 over 3. So the last step is sometimes to do one more final reduction. $15 and 12. They both divide by what? So divide both by 3. So I get 4 radical 5. 5 radical 12 divided by 3 is 4. So 4 radical 5 over 5 radical 4. Step 2 is to simplify the radical. Can I simplify either one of those radicals? I can simplify the 4. So the top one I'm still stuck with. The bottom one, this 4 can change into a 2, so it's actually 5 times 2 down here, which is a 10. Now, like I said, a lot of these bottom ones, you're going to have to do one final reduction. So I have a 4 and a 10. Don't do anything with the 5, because the 5 we're stuck with now. 4 and 10 can both divide by what? 2 again. Try to chop the 4 and the 10 in half. 2 radical 5 over 5. So like I said, the main reason we're doing that is just to get us ready for tomorrow. It's a little side trip. It's a little detour. We're taking a scenic route. Because, like I said, the algebra teacher said they really didn't get to this last year. And we're just doing kind of the basic ones because we don't need anything too extensive for what we're doing, but we do need to have a little bit of an idea of what we're doing. 18. Is there anything that can come out of the 5 and the 45? 5. So take a 5 out. Take a 5 out. So 3 radical 1, 5 radical 9. 3 radical 1. Well, like I said before, radical 1 is just 1. And 3 times 1 is just 3. So this top I can just write as 3. Because the radical run doesn't really do anything for me because that's just 1. And 1 times anything is going to be the same thing back. The bottom, what can the bottom turn into?
30.
So the 9, radical 9, square root of 9 is 3. So I already had a 5. Square root of 9 turned into a 3. So 5 times 3, 15. So I get a 15 there. Now I do have one last reduction now. So 3 over 15 changes into 1 over 5. So 1 over 5. Question 8.
Why wouldn't it be 3? Like 1 over 3? Because they both divide by 3.
What's 15 divided by 3?
5. Oh.
Are we all right? Last 2. $19. Reduce the radicals. I have a 20 and a 4. What can come out of 20 and 4? 4. Yes, 2 works, but 4 is better. So 3 radical 5, 2 radical 1. Well, I don't even need the 1. So 3 radical 5 over 2. And 1 to go. 4 and 64. What comes out of both? 4. So 5 radical 1, 3 radical 64 divided by 4. What's 64 divided by 4? And this is what I meant. I mean, for the most part, you won't need a calculator on this, but occasionally you might need one for a little bit of math. You get 16. So that's a 16. But I don't want you to try to get decimals on these things. You're not supposed to get decimals on special right triangles. You're not supposed to get decimals when you work with radicals. Now, I guess when we did Pythagorean theorem, I let you do the decimals, but these, we're not doing that. So the top is just 5. The 16 is actually 4. So 3 times 4 is 12. So that's my final answer there. So these. Sorry. Okay, so for the most part, we're just doing them together. Easy points, just by doing them together.